Alrighty, hello everybody and good morning. And then I'm super happy to be here. And then I saw a lot of people in this morning and the long line in the entrance today. Yeah, so I'm from actually Boston. It's a pretty similar weather, like it's a windy, cloudy, rainy, similar thing. Okay, and thanks again joining my session today. I'm going to really talk about a few interesting live demo around the serverless Java. And then so my name is Daniel. I'm working for Red Hat as a developer advocate. I'm also Java champion and CNCF ambassador for the last 5 and 6 years to meet a lot of people just like you, smart people, not only developer, but also DevOps and engineers and the platform engineers and SRE, whatever they call, and full stack developers. And it gave me a lot of opportunity to understand what their challenges are and then what is their goal to overcome not only application development, but also how to bring their existing business application into cloud, like a Kubernetes or like a public cloud, Amazon, Google, and Microsoft, things like that. Here's my contact information, our social media, Daniel030, like a Twitter, LinkedIn, and then YouTube channel, and then like a GitHub repo, so you can just find me anywhere. After this session, if you have any question around this topic or my expertise, like a Quarkus, Java, JavaScript, or cloud and GitOps, something like that, and serverless as well, yeah, please reach out to me anytime. And then, so one of my friend and colleague, and Kevin DeBoer, he goes to talk about cloud agnostic design pattern and tips specifically serverless Java. We actually working together writing new book with Manny. So if you have any chance to just stop by his talk in 3 p.m. in the Doc Stage 3, you can find a more interesting pattern for your real life for serverless Java application development. So I feel like a lot of people actually have some experience Kubernetes. And what is the benefit of the Kubernetes? Yeah, Kubernetes, yeah, they're a fantastic capability, like auto-scaling specifically. So traditionally, like an operation team, they manage like a scale up and down based on seasonality or some heavy workload. However, Kubernetes actually changed that kind of stuff. So when you deploy app to Kubernetes as a container technology, like a Docker or Podman, whatever you call the OCI format, and Kubernetes keep monitoring your application like a health check or readiness, liveness, and then like a networking traffic and so on. And once Kubernetes find out, oh, you need to scale up, like scale in and out, and then it really happen based on HPA, also known horizontal power autoscaler, based on CPU or memory utilizations. So that is the beauty of Kubernetes. Just like this diagram, you have a bunch of the Microsoft's application for specific domain or multiple domain in one spaces or multiple project, doesn't matter. So for example, here there are some online shopping mall here or online retail application. Inventory, catalog, order, and card and payment is all single microservices based on like a Java, .NET, Python, whatever you want. And then each microservice is managed by HPA CR, customer resources in Kubernetes. And then once you got some network traffic based on like a human or mobile devices or IoT edge devices, it automatically scale out. That is the beauty of the Kubernetes. But the problem is it came out in the reality, you have many external services here. Not only Kubernetes, but also some application actually got some network traffic from external services, which it could be like an event-driven application from Kafka cluster. You can actually run Kafka cluster inside the Kubernetes, but also you already have existing infrastructure for Kafka cluster, like a open source project or Confluent, any kind of Kafka infrastructure. And then so you don't need to bring all infrastructure into Kubernetes. Maybe your company is not ready, or you wouldn't do that because you already spend a lot of money and effort and time to stand up the infrastructure externally out of Kubernetes. And still, your application needed to process the network traffic, like event messaging from Kafka cluster or Prometheus based on metric, based on some auto-scaling or some public cloud. For example, the Amazon Cloud Watch or Azure Monitor. Based on that telemetry data, you need to scale in and out rather than just inside the application resources utilization based on CPU and memory. So how to handle actually by Kubernetes? So luckily, Kubernetes provide like a custom matrix, like some of the adapter for your application. So you can actually create a custom matrix based on Kubernetes specification. For example, you can create a metric adapter for Amazon Cloud Watch, and then a Prometheus metric adapter, and then Azure Monitor metric adapter, something like that. But for example, for integration of Kafka cluster, you cannot do that directly. But you can actually create the Prometheus metric adapter, which goes through Kafka cluster. But the problem is here, you can only enable just one of them adapter at once. But you cannot be sure all metrics are related to one single adapter. For example, here the older application actually scale in and out based on Kafka metrics or event messaging. However, like a catalog inventory application needed to be scaled in and out based on the Amazon Cloud Watch metric data. But you cannot do that in this auto-scaling architecture on top of the Kubernetes. So that's exactly a new CNCF project, which is already graduate in CNCF like last year. It's a KEDA, Kubernetes Event-Driven Autoscaling. This project actually tried to solve this kind of challenge. So here's just some time frame. What happened in KEDA project is invented back in 2019. Red Hat and Microsoft actually have some strong partnership to invent this project. And we actually donated CNCF Cloud Native Computing Foundation, which is a standard all cloud native projects. And then it eventually graduated last August as the graduate project. And a lot of companies actually bring this project and they productize as some commercial services or commercial product. So this is like a proven technology. So I'm not going to go through every single detail of the KEDA. That is not my goal of this session. But just slightly quick take a look at what KEDA is. So it's automatically scale Kubernetes resources like a deployment and job and custom resources. You don't need to change any existing Kubernetes resources, which means I already deploy my apps Kubernetes, like a deployment or job, something like that. And in order to enable KEDA stuff, I don't need to change any running apps and resources. I just enable and targeting existing resources. That is the beauty of the KEDA. So, which means developers perspective or DevOps engineer perspective, I don't need to think about the migration jobs at all. And there are more than 64 built-in scalar, like a Kafka, Prometheus, and RabbitMQ, many kind of external services. And you can enable multiple services at the same time, rather than just enable one adapter, like a Kubernetes metric adapter. You can install KEDA using operator or Helm chart whenever you prefer. And then now you can see that we just optimized this auto-scaling architecture, so you cannot see HPA resources for each microservices right now. So we replace scaled object from KEDA, and then the beauty of the KEDA actually you can link to HPA object in based on Kubernetes because the KEDA actually running on Kubernetes. And now, so the scaled object was scaled job and KEDA only manage like a 0 to 1, 1 to 0. That's all. However, I need to more rather than one pod because I got maybe 1 million telemetry data from Kafka cluster in the next 2 minutes. One pod is not enough to process that kind of millions data. So it could be like 100 or even 10,000 container pods scale out in real time. So that is exactly KEDA scale object trigger HPA to scale out more than one pod. And then this is some overview, like some architecture and how KEDA works. And then it's I already mentioned earlier the KEDA only manage existing Kubernetes resources, and then it impact existing HPA, scale out more than one container pod. And some example on the right-hand side, how to define, how to create a scale object, which is very simple. Let me show you that in my real demo. And then you can find that some of it here. So targeting resources and then what is the trigger could be Kafka, could be Prometheus, could be another external service, which is very simple. That's exactly how it works. So you don't need to change any existing Kubernetes resources right now. So, but I got one question because I got to ask a lot of questions from developer and the SRE engineers. When they think about serverless, because so KEDA is not 100% serverless stuff. Because you mentioned about that, it scale 1 to 0, 0 to 1, but when it impact existing running resources, which is still running on like all the time, which is not serverless at this moment. But once you impact KEDA scale object into running pod, and then starting to monitor some metrics, and then if you complete processing all metric data, and then KEDA let pod goes down something like a 0 at a time, and now you got some very similar behavior of serverless. But at the very beginning, it's not serverless because your application is still running on all the time. But serverless, fundamentally, when you deploy the app as a function at the start, and then when you finish your job, it's automatically and literally scaled down to 0. That is a fundamental behavior of a serverless. But the KEDA is not 100% serverless. So that's another project, like a Knative project. It's another CNCF project actually came out. It's 100% take care of serverless. Oh, this is something weird. So let me try to go back, and then again. There we go. So this really, I got to ask a lot of time. So KEDA, Knative is similar, like a pronunciation and project name, and then all starting K, and some people use this two terminology interchangeably because it's all kind of serverless or autoscaling or Kubernetes. But let me try to distinguish what difference between two projects are. So KEDA is only managing existing Kubernetes resources like a deployment job. However, Knative project, you need to create a brand new resources, which is a Knative services, which allows your application to deploy as a serverless function on top of the Kubernetes. And then their own autoscaler. So KEDA actually trigger existing Kubernetes HPA, the horizontal part autoscaler, but you don't need to create a new autoscaler. However, Knative, you need to create you have needed to use your own autoscaler, which is a Knative autoscaler. So there are some change stuff, but the one big different thing is between KEDA, Knative. Knative only manages like a scale down to 0 and just 0 to 1, no more pod, regardless of the resources and network traffic. So let me show you 4 different demos today, based on use cases. So this is the first use case is the basic Kubernetes autoscaling architecture when you saw the first diagram at the beginning of the session. So application, there are a simple application, and then we're going to scale out based on CPU utilization, based on horizontal pod autoscaler. And then we're going to just consume millions of data from Kafka cluster right now. So let's go back, change my demo environment. Yeah, here's my Kubernetes cluster, which is a Red Hat developer sandbox. It's for free. Any developers, you can just go to developers@redhat.com. You can just sign in with your email address, and then we're going to give you some verification based on your email, and then you can have a free Kubernetes cluster, which is a Red Hat OpenShift for next 30 days. And after 30 days, we're going to send you out some email notification. Yeah, you were the sandbox will be deactivated because the time's up. And then you're going to reactivate it right away for free again. But this is not 100% cross-admin permission because we're not going to let you ruin entire system. So you have some limited permission to deploy some of the application, and they're already deployed a bunch of the operator, Kafka or serverless, and then like even cloud ID based on VS Code, something like that. So the first use case, I already deployed my Quarkus application for Java. So you can actually deploy any kind of Java framework, like a Spring Boot or Pojo Java or JBoss EAP or WebLogic or Quarkus. So let me explain why I choose Quarkus for Java apps soon enough. And then I just deployed Quarkus app. This is my Kafka cluster based on Zookeeper and all deployed at all. And then when you just check it out, and then you can see that Quarkus already deployed and then automatically linked to my topic, which is named my dash topic on Kafka cluster. And then Quarkus project community is a brand new Quarkus Java framework invented by Red Hat and then many community developers, which more targeting increasing developer productivity and also Kubernetes native Java apps. And so we release almost every 2 weeks new Quarkus minor version. So 3.8.1 we just released 2 days ago. And then you can find a bunch of the extension, which is like a Maven dependency or enterprise capability already enabled, like a Kafka messaging and for reactive deploying based on Vertex. And also here is the Kubernetes as well. So let me go back to here and then go to my project. Let me try it a little bit bigger. Hopefully everybody can see that. And then this is the first project, and then here is the like a Java project, like a Maven based on project, and the Quarkus version 3.8.1. And then a bunch of the extension here, Kafka messaging and Jackson for processing JSON format, and then OpenShift extension, which allows me to generate automatically Kubernetes resources. So when you go to like a Java project, you can find a very simple application here. Just one Java method, like a receive record from Kafka topic. It's one annotation incoming. This is allowing me to connect to Kafka cluster automatically. So pretty simple. That's one of the reasons I use Quarkus for reactive programming and event-driven programming. I don't need to implement very complicated interface to connect to Kafka cluster. I can just use one single command line annotation, like incoming, which is I just receive a metric or message from Kafka cluster. I can send it to Kafka cluster with the outgoing annotation as well. You can also set up your Kafka information under the application properties or YAML file. So here is my topic name, and then here's my Bootstrap server, something like that. I already deployed to Kubernetes, which is a service name, not like a fully qualified domain like a www.daniel.com, kafka.com, something like that. So, and the other reason I use Quarkus here, so when you needed to create a Java app and then deploy to Kubernetes. So what have you done that for inner loop and outer loops? You need to like containerize the app, like using Docker CLI or Parliament, whatever you need, using Docker file. Well, you can create a Docker file as well. And then you're going to create some Kubernetes manifest, like a YAML file, like a bunch of stuff. Where's my image path, like some Docker IO or Docker Hub, Core.io or Google Container Registry. And then what is some replica or deployment or service, all kind of the manifest you need to specify, which is just some hassle because you don't need to learn about that. Some people say, oh, yeah, YAML is a pretty similar JSON. It's pretty much easier, but that's not true. So I've been there, done that for a lot of years. So, but Quarkus actually automatically generate the manifesto. When you go to Target, when you build application like a Maven package or Maven install or Gradual, it automatically generate Kubernetes directory under Target directory, which is generated like a Kubernetes YAML or JSON file. It automatically generated based on your project artifact, like some Maven POM file or something like that. You just run this YAML file using kubectl, like a kubectl upright -f some file. And one of the good things is when you deploy to OpenShift, like a developer sandbox, we already integrate that Kubernetes cluster. You don't even need to use kubectl. It automatically connect to OpenShift cluster, Kubernetes cluster using API. And then, so you only need to run single Maven command line. That's all. So I already deployed that, and then I already created HPA, which is a horizontal part autoscaler. I just set up for my demo 60%. If you the incoming natural workload is more than 60%, it automatically scale out. And then now it's 0, there's no traffic. And I'm going to create some performance test of my app. Luckily, the Kafka cluster, it includes some batch job here. Let me go to here. It's a performance batch job, like a performance test. It's inside the Kafka container. So it's targeting my topic, and the throughput is 1 million. I'm going to parallel 5 here. And then it's the 10,000 milliseconds is 1 second. Every 1 second, I'm going to create a dummy record. And then 5 parallel power, which is a 5 million metric event messaging just generated and then sending to Kafka. And then Quarkus application consume that 5 million Kafka event messaging and try to process in the next couple of minutes. So let me try to copy all kind of stuff. And then I'm going to create a YAML file. You can actually using kubectl or whatever you want. And then I'm going to go to topology view. And then it will show up here. Okay, let me try to here. And then you can find the Bible pod. It's automatically created. And then when I check it on one of the pod logs inside of that, you can see already almost 4,000 records almost generated. It's going to be generated and to 5,000. But this is only one pod. You can go to another pod. It's there. Keep creating a bunch of the dummy record. And then when I check it out my Quarkus app, and go to view log, and my Quarkus app going to crazy. Oh wow, there are many data is coming to my app, and then I need to process that. But here is a tricky part. So Kubernetes keep monitoring based on HPA to decide when the application scale in and out, but it takes time. So that's the HPA is not good practice for event-driven auto-scaling. Doesn't matter Java or .NET, Python. But I want to say event-driven auto-scaling based on only HPA is not a good idea. Because it's already, you can see that the line of just more than 63,000. But it's my app is going crazy. But when I go back to like a HPA, the analysis, you can see that 64%. So when I go to it should be scaled out like it could be in up to 2 pod, but it's too slow to scale out. In the meantime, maybe your application may be out of memory or some of the deadlock or some maybe overflow. So that's the reason why we need to think about the other use cases. So how do we optimize or improve this auto-scaling architecture, which is I mentioned the KEDA. Okay, let's give it a try. The KEDA, how to make it different. So in this architecture, you can see that KEDA actually keeps scrapping metric from Kafka cluster, and then just it's time coming up, and then Kafka just let application you need to scale out. So that is some basic mechanism of how that works. And then let me go back to demo environment, switch another project like a KEDA. I also deployed the Kafka cluster again, but there's no app right now. And then when I go back to project, you can actually deploy manifester. This is my manifester deployment. And I already set up the Kafka stuff. And then here's my, I already push it into Quay container registry with the same application. Let me try to just deploy my app using YAML stuff. And then it's going to be start out soon enough, but the Quarkus is super small and super fast. And then you can see that. And then view logs, and then coming up soon. So application is coming up right now. And then I can I need to also create a scale object of this only thing I need to enable KEDA stuff. And now you can see that what is the target thing is the deployment in Quarkus EDA demo, and then what is your trigger is Kafka, and then Kafka topic, and then here is the Bootstrap server. That's the only thing I need to. You can set up or like Kafka or a messaging queue or any kind of Amazon SQS based on the Bootstrap server, and the targeting is your deployment name. Because when I go to here is my deployment name, Quarkus-EDA demo. So let me try to create this kind of thing. And then go back to topology view. And then just to make sure my application ready to auto scaling, just now one part. And then back to here, I'm gonna just run the performance test bash script, bash YAML, and just create the once again. And now you can see that. So it's creating a 5 part again here, and it's going to generate 5 million dummy record right now. And then now you can see that it's already start scale out to 4. It's literally happened. And then it's gonna be scaled out to like a 10 soon enough because I set up the maximum scale 10, but I don't want to ruin my entire demo system. So you can already just set up like a min-max for scalability with some consultation with the DevOps engineer. They don't allow you scale unlimited part. So like it's already in the meantime in the scale out 8, and then you're going to scale out 10. It's pretty fast. Now we can scale 10 at the maximum capacity. When I go back to first project in HPA, and then just take a look at how things are going here, and now it's still 1. Maybe it's a scale out 2, and it's back to scale 1. And then, but it's not done because as you can see, the job is still running. And then when I check it out, my Quarkus app, is my Quarkus app still maybe crazy busy right now here. Yeah, there's some kind of problem, symbol link. Okay, let me try to view again. Yeah, so still crazy busy. So not enough the HPA with the eventually auto scaling. It's just a 5 million. It's not a big number. Just imagine that you have some business application and the running on spread around the world. Specifically, since a pandemic, a lot of people actually connect to your app. Doesn't matter like a mobile app or a tablet PC or some of the stuff in desktop. Everybody work from home, which means that you might need more high workloads rather than you expect before pandemic stuff. And then this is a KEDA stuff, but the problem is KEDA is not 100% behavior of serverless. So let's give it a try. How do we handle 100% serverless, which is based on KNAB? Let me give it a try, the KNAB without KEDA, because I gotta ask a lot of time. Hey, Dan, you just mentioned about serverless, and then I think so. We got 2 choices. One is KEDA, the other one is KNative. So which one I needed to choose? Sure, it depends on, the answer is always depends on your expectation and your skill set and your familiarity. However, it's really hard to choose one of them. But this is just cool demo, try to understand what difference between 2 projects. I just replaced Knative, but as you can see, Knative not directly monitor Kafka, but there are some inventing infrastructure which is called the Knative eventing. It's also like some of the process or part. They actually are consuming. So weird. Yeah. Okay, so this kind of stuff. And then this Kafka, the data actually consuming from the Kafka source is on Knative eventing. And also you need to rewrite your application for cloud eventing processing, as well as deploy as a new format of Knative service rather than existing one. Maybe this is just some burden of developers to design, like a senior architect, also maintaining by your DevOps engineer team as well. So let's go back to switch new project here, Kafka Knative. And then now it's an empty project except for Kafka cluster. And go back to my project and then switch to new project. And then first thing is, I'm going to go to project, and then it's pretty much similar, but you might need to some processing cloud event stuff, which means developer standpoint, you need to modify or modernize your application, communicate cloud events. Cloud events are some kind of CNCF project to process like agnostic event messaging stuff, because you might need to use your event messaging based on JSON format or a protobuf or binary. So how to communicate among other the formats? The cloud event actually gives some standard format, multiple event infrastructures. So KNAVE project actually recommend use cloud event for Kubernetes environment. So this is the way, and then one interesting part, and then go to application property, and now you can see that. So previously, let me go to the previous project, and then property, and then now you can see that deployment target was OpenShift. You can actually set a Kubernetes, which is a vanilla Kubernetes, your own Kubernetes, or AKS, EKS, like some of the public cloud Kubernetes services. You can also set it on OpenShift, which is targeting like a developer sandbox or Red Hat thing, or you can set Knative, which automatically create the Knative resources. As I mentioned earlier, you need to rewrite Kubernetes manifesto from like a deployment to Knative serving. In order to that, you need to learn how that works and what that looks like. But the Quarkus actually, with that one single property, automatically generate that kind of thing. So let me try to go to command line and then just check it out. Where is my project right now, which is Kafka Knative. And then let me try to run my Quarkus project. You can actually use Maven command line, like a Maven clean package or install, something like this. Very similar command line, but very handy for me because I don't need to remember all parameter or argument on a Maven or Gradle. And also it's an auto completion feature which allow me make it really fast demo stuff. And then so finger crossed the network bandwidth here. So in the meantime, so Quarkus project automatically generate Docker file for JVM and also the native executable, which is a literally executable file like some Windows executable extension file. It makes Java super small and super fast. For example, if you created a few RESTful API in Java application in Quarkus, it takes less than half a second to start up. A few less API. When you packaging native executable, it takes like a 15 milliseconds to start up. And the memory footprint with that RESTful API on JVM, let's say like a 90 megs to start up, even after first invocation. And native executable is 10 times less than like a 9 or 8 max to memory footprint. I don't want to say you already build native executable compared to Golang or Python.NET for Java apps, but sometimes you need to think about high order scaling, like a scalability or serverless with a native compilation with Java, which is pretty awesome. So Quarkus was born with a native compilation at the start. So you can actually, you don't need to create a Docker file. Quarkus actually provides that kind of stuff. That's why you can see that some Docker step here is that, oh yeah, I need to compile. And then this Docker build actually not happen in my local machine. It all process running on remote Kubernetes cluster. I don't need to even run Docker runtime or container runtime like a Docker Podman locally. You can actually do that if you prepare. So it's a build success. When I go back to my application, and then my application coming up, and then it shows the Quarkus same application like a 381, and then it already enabled some of the stuff. Now you can see that. So the same project, I'm not gonna cheating on you. So 381 and all kind of stuff here, the same extension and capability here. And then, as I mentioned earlier, Knative services actually need to Knative eventing, which communicate between like a metrics server infrastructure, like a Kafka, and between your Knative and application. So let me try to create the Knative eventing infrastructure, which is a Kafka source. You can see here where is my Bootstrap server, and then where is my topic. So previously, I need to set this kind of information into my application side, like application properties. But now I don't need to do that because when I go back to my application property, I don't see that any kind of thing because it delegates to that infrastructure layer. Maybe developer standpoint, it's not my job anymore. It's your job, DevOps engineer. No offense, DevOps engineer here, but here is how that works. And I just go back to, and I'm going to try to import the Kafka source here, and then create that. Go to topology. And make sure, and then now you can see that it automatically attaches Kafka source. Maybe you can change it, the label. Make sure this is a Quarkus app. And then, okay, and then go to one thing I want to show on the target directory in Kubernetes. Now you can see that Knative YAML file is something different. Only the one configuration. What is the target deployment is Knative automatically generate Knative. So that's exactly deploy serverless on my app. So now it's the application gone, so there's no scale down to 0. It's literally serverless. While I was talking, there's no traffic. It's scaled down to 0. It's literally 100% serverless behavior, like Amazon Lambda, Google Azure function, and Google Cloud function, something like that. So let me go to just run the job file here, the batch job, and go back to here, and let me create that, and then go back to topology view, and then now you create a new job 5, and soon enough, so my application scale just 1, just like a serverless, like a cold start, like a strategy, something like that. And when I go to my app, and then it's gonna be consumed the holy crazy 5 million record from the Kafka cluster. The problem is there are only one pod needed to process 5 million. That is just some limitation of a Knative project. But the KEDA is to scale out the maximum like a 10,000, whatever you want. However, it's not start from serverless at the beginning. So a lot of people actually some concerns. So which one I need to choose between two projects? But you know what? And then so that's actually the beauty of the open source ecosystem. So KEDA Knative actually integrate some of the new sandbox project. So you can actually use both at the same time, but some limited use cases, not all use cases. For example, open source ecosystem change every single day. So for like a observation area, you might use the open trace or open census, but now it's emerging into new project, open telemetry. It's the second largest contribution in the CNCF right after Kubernetes. So it's happening all the time. So now everybody asks me, hey, Dan, which one I need to choose? You don't need to choose. You can actually use both. That is KEDA kind of integration. And then, so still some of the limitation here because it's still a working project here. And then a little bit complex diagram. And so one thing here is the KEDA still keeps scrapping metric data from Kafka cluster. And then, but ask for Kafka source, which is a part of Knative, hey, you need to scale out. But also Knative project is scale out to application itself. So it's not only scale one targeting actual app, but also infrastructure scale out at the same time, which allows me have a more flexible auto scaling. Because auto scaling is not just scale out at once, it needs to scale in and out dynamically and flexibly based on your workloads. If you scale out 10 pod and your pod is job's done, okay, I'm going to scale in again like a terminated. If you more workload, I'm going to scale again. rather than scale it to maximum and waiting for all job done. Because it's a serverless, the goal of a serverless is reduce and save your infrastructure cost. So which one would be better? So this is my last demo, and I'll go to one last project, KEDA, Knative, and then nothing in there. And then, so let me go to change my app a little bit. So I'm going to change the image group, which is actually Kubernetes namespace name. So now I'm going to change it to Kafka, KEDA, Knative. And here is the some interesting stuff. Knative, you have to actually specify YAML file. But the third reason of I choose Quarkus today is actually give us some capability of programming way to you can actually set up autoscaling, and then stop here. I'm gonna set up, and then now I'm gonna go back to terminal and then change my project to Kafka, KEDA, Knative, and then I'm gonna try to run my app once again, and then it takes a few minutes, and hopefully finger crossed, and then by the way, I'm gonna using Java 21. So I actually visited Amsterdam Jog last night, and then I gave it a really good communication with them, a lot of Java developer around Quarkus and the Java 21 and the virtual thread. So that was a really interesting communication. If you have any question around that, yeah, just feel free to reach out to me, ask any question. And then back to the application. And then one thing I needed to create a new Kafka source, but this is a little bit different. As you can see, there are a few annotations around KEDA and Knative integration. These few annotations actually enable you integrate two projects. It's pretty simple. You don't need to run something complex syntax or SDK for developer standpoint. Okay, I just need to use both, but I let some people from ops team install the operator or Helm chart for Knative and KEDA infrastructure, and I just deploy my app and I just use the two infrastructure, which is make that happen by this simple annotation. This is for KEDA, Knative for targeting Kafka. You can also targeting the other infrastructure. Let me show you that right after the demo. And then once deployed, I need to create the dev resources again. So it's almost done. Should enough soon enough. I finished that. Okay. And then when I go back to my project, and then some Docker files, some of the people are actually asking me sometimes, why you have 4 different Docker files here? Because normally you can deploy application like a JVM, like some Quarkus actually using fast jar rather than thin jar or Uber jar and the legacy jar, because we override Java class loader, which allows our app make it really fast start. Like I mentioned, like a few REST API you could start like a half a second. That's we override class loader. That's why we renamed the jar name like a fast jar, but not generate right on the target directory, like 2 levels. But sometimes your infrastructure only point to just 1 level job file pass like on the target directory. In that case, you can generate like a legacy jar, like a Uber jar. You can also deploy a native build executable. And sometimes the native, we need to small, tiny native image. In that case, we provide some base image, like a very small micro base image. But specifically, we need to deploy this app like the edge rather than like some cloud. Okay, just done, and then back to my app is here. Let me try to create a new Kafka source, and it automatically attach. And then one more thing, I needed to copy the job again. And then let's give me a few seconds to scale down to 0. Maybe just for fun, I'm going to make sure this runtime is a Quarkus, which allows me identify which application I just used that. This is a Quarkus, this is a Kafka, this is like a PostSQL, this is a .NET, or even Spring Boot, something like that. So once it's scaled down to 0, I'm gonna just run the batch job, and then we're gonna take a look at how fastly scale in and out, flexibly, dynamically based on event messaging from Kafka cluster. So I have a few slides in the summarize. Okay, it's terminating right now. And then, so give it a few more seconds, and then it scaled down to 0. Because the Knative project default scale down to 0 period is 30 seconds. You can actually change add the cluster element. You can define, oh, we need to 60 seconds or even 5 minutes. But 5 minutes is not good idea for serverless behavior though. So okay, now it's gone. And then I'm gonna just create a new batch job, and then back to the topology. And then once you create that, it's automatically scale out my Quarkus app based on some event messaging from Kafka cluster. So now you literally see that it's automatic startup, and then 4 and 5, and then it's a little bit up and down, like a 8 to 4. It's based on the jobs done, based on like a workload, something like that. So pretty much flexible because it's not only scale, managing scale in and out application itself, but infrastructure as well. So when I go back to KEDA project, it might be scaled down to 0, a few minutes later, and then still it's a scale out to 10. It's a maximum capacity, even 20 minutes later. And then what about the Knative? And then Knative is still just one part. And then back to the Knative KEDA integration. And then it's a 5. I don't need to scale out to 10 at this moment because of this whole integration stuff judges, 5 pi is good enough to process current incoming traffics. If you need it more, and I'm pretty sure to scale out dynamically. So let me go to summarize today's session. Running over time. A few takeaways here. So KEDA is basically super simple. You don't need to change anything on existing apps. So in your company, okay, we need to think about auto scaling, but we don't need 100% serverless behavior. And then more important thing is that we don't need to change anything in production because we already make a stable state. In that case, KEDA may be a good option. However, we need 100% serverless behavior and just something like that. We are more than happy to rewrite some of the application and infrastructure as well. Knative should be good. But we also need to high scalability, maybe not good for Knative. So in some more that use case, maybe KEDA, Knative integration would be better. So I already posted this kind of 4 different demos separately in my YouTube channel. So YouTube handler Daniel30 or bit.ly URL Daniel TV. You can scan the QR code and subscribe. And then ask me anything around this demo videos, around any kind. I already posted more than 100 videos, technical tutorial, not only serverless and GitOps practice and Quarkus, Spring Boot, Java, and JavaScript, and DevOps. So you can give me some inspiration as well. Hey, I'm looking for some technical video around like a GitOps or Argo rollout or something like that. I'm more than happy to create it for you. So, and then let me go back to last thing. So now you can see that it's a 10 part, but not really scale out to 10, and it scale down to like a 8 or 7 based on the network traffic for sure. That's it. That's all I have today, and thanks for attending. And then if you have any question, I'm going to be around for a while. And then please enjoy the rest of the conference. Thank you so much.